Alright, so in this video I want to talk about trig functions evaluated at some important angles, and there's different ways to go about doing these problems. The way, again, I'm going to talk about them is the way I go about doing these, and I think we've seen this in some other examples. I remember basically this the first quadrant of the unit circle, and again, we've got the angles listed: pi over 6 equivalently 30 degrees, pi over 6 radians and 30 degrees, pi over 4 radians 45 degrees, pi over 3 radians 60 degrees, pi over 2 radians 90 degrees, and the corresponding points where those angles would hit the unit circle. And again, the thing I remember is cosine of an angle is simply defined to be whatever the x-coordinate is at that angle, and sine of theta is defined to be whatever the y-coordinate is at that angle. So, here's a few. I think we can grind through all these. I think the only one that's really going to take sort of any work is going to be part B of these examples. So I think the others we can simply read off from the unit circle. So, okay, so sine of pi over 6. Well, sine of pi over 6. Again, what I do, I simply find the angle pi over 6. Okay, there it is. I think, where does that hit the unit circle? Well, it's going to hit the circle at the x-coordinate of square root of 3 over 2 and the y-coordinate of 1/2. And again, you can justify all this stuff using geometry and 30, 60, 90 triangles. At some point, you're going to use this stuff so much, though, you don't want to derive this every single time. So, to me, it's absolutely imperative. If you're going on, you want to have this stuff memorized to some extent. You just have, it's so fundamental that you want to do that. So, okay. So again, I find the angle pi over 6. Hey, there it is. I think about the point associated with pi over 6. There it is. Sine of pi over 6 is simply defined to be whatever the y-coordinate is. So the y-coordinate there is simply 1/2. So we would say, well, sine of pi over 6 is 1/2. Let's skip part B here for a second. Let's do C and D first. Cosine of pi over 4. Okay, so the first thing I'm going to do is find the angle pi over 4. There's the angle pi over 4. I think, what point is that hitting on the unit circle? Well, square root of 2 over 2 comma square root of 2 over 2. Cosine is defined to be whatever the x-coordinate is. Well, here it's kind of hard to mess up because they're both the same, but we would say cosine of pi over 4 is the x-coordinate, which is just going to be square root of 2 over 2. Okay, so nothing to really do as long as we have this unit circle memorized a little bit. Okay, secant of pi over 4. Well, remember, secant of pi over 4, that's the same thing as 1 over cosine of pi over 4. We already figured out what cosine of pi over 4 was. It's square root of 2 over 2. So I'm going to squeeze it in here. If we do 1 over square root of 2 over 2, that's just going to flip the fraction in the bottom and give us 2 over square root of 2. And again, some people will simplify this. Let me take a different piece of paper here. So 2 over the square root of 2, we can rationalize the denominator by multiplying by square root of 2. But we'd have to do the same thing in the numerator. So we would get 2 root 2 over the square root of 2, and the square root of 2 will just give us 2. We can then cancel out the 2's. We're left with square root of 2. So we would say that secant of pi over 4 is really just the same thing as the square root of 2. Alright, let's figure out our tangent of negative 5 pi over 3. So this one's going to be a little different. This is where we have to kind of use reference angles to evaluate this one. Okay, so I'm going to think about the angle negative 5 pi over 3. Well, I can write negative 5/3 as negative 1 and 2/3, and then our pi is still left over. So if we go negative pi radians, that's going to take us clockwise. We'll be sitting at the negative x-axis. And then we would have to go another sort of negative 2/3 pi around, which is going to take us somewhere into the first quadrant. Okay, so that'll be negative 5/3 pi. Had we gone all the way around, we would have gone a distance, we would say we were at the angle negative 2 pi radians. And again, to find the reference angle, what I do is simply make them both positive, and I subtract the smaller one here from the larger one. So 2 pi, we could put that over 1. We could multiply top and bottom by 3 to get common denominators. That would be 6 pi over 3 minus 5 pi over 3, which would give us pi over 3. Okay, so the idea is to evaluate tangent of negative 5 pi over 3. I'm going to say that's the same thing as, okay, tangent of pi over 3. Now you have to be careful. You can't just interchange the original angle with its reference angle. But the thing that I recognize is tangent of negative 5 pi over 3 is going to put me in quadrant 1. Tangent, by definition there, is going to be a positive number. At pi over 3, tangent is also a positive number. So these, in fact, will be the same. Alright, so to get tangent of pi over 3, well, I simply remember that tangent of pi over 3 is sine of pi over 3 divided by cosine of pi over 3. Okay, so now I'm just going to go back to the unit circle and read these values off. So let's see, where's pi over 3 is up there at the top of the circle. So I'm going to find the angle pi over 3. There's the x-coordinate of 1/2. There's the y-coordinate, root 3 over 2. Sine of pi over 3 is by definition whatever the y-coordinate is. So that's going to be the square root of 3 over 2. Cosine of pi over 3 is by definition whatever the x-coordinate equals, which is 1/2. So cosine of pi over 3 is 1/2. Sine of pi over 3 is root 3 over 2. Let's plug in our 1/2 here. And we can simplify by taking our bottom fraction, flipping it, and multiplying. The 2's would simply cancel, and we would be left with the square root of 3. So tangent of negative 5 pi over 3 is the same thing as the square root of 3. Okay, so let's go ahead and finish off this last part. So we now figured out what sine, we figured out A, B, C, and D, all of these. Our last problem, we're going to find sine squared of pi over 6 plus cosine squared of pi over 4 plus tangent squared of negative 5 pi over 3. So remember this notation, when we put the square in the middle, that means the same thing as, you know, all of that in parentheses with the square outside. So I usually, even now, I tend to rewrite these just because I like to see it. I used to always be confused by this notation for some reason. So I like to see the squares on the outside, and somehow it's less confusing to me. But we now have all the values we need. We figured out that sine of pi over 6, we said that that was 1/2. So we'll get 1/2 squared. Cosine of pi over 4, we figured that out, and that was square root of 2 over 2. Again, that's going to have to be squared. We figured out tangent of negative 5 pi over 3. We said that was square root of 3. And again, we would have to square it. But now I'm just going to do the arithmetic, and we'll try to clean this up a little bit. So 1/2 times 1/2, you just square the top and square the bottom. 1 squared is 1. 2 squared would be 4. The square root of 2 squared would simply be 2. 2 squared would be 4. And the square root of 3 squared would simply leave us with 3. Well, 1/4 plus 2/4 would give us 3/4. And we're adding to that 3 over 1. So we could multiply the numerator and the denominator of our second fraction, our second term here, to get common denominators. And that would just give us 3 plus 12 all over 4. Or we could say that's going to be equal to 15 over 4. So, alright, again, the moral of the story, to me it's good to know this first quadrant. And again, everything, using reference angles, I can evaluate a lot of trig functions just by thinking about the reference angle and then just thinking about this first quadrant of the unit circle. So again, definitely not mindless, but again, personally, I would not want to do geometry to, go through all the definitions to derive these. And again, at some point, you're expected to know them. So I say the sooner you commit this to memory, the better off you'll be, at least in your trig classes.